basically being convertible for recruiting stuff.
You guys can go over today.
Is it still open agenda? Yeah.
Open agenda, basically. There's a couple things that I'd like to maybe chat about. I don't know if Ron's actually going to be able to join. I think Joe is going to try and jump in later. But yeah. Maybe starting with just like basically where things are.
You've been looking at the pull requests, yeah.
Yeah.
Is yours coming in soon?
So the thing that I would potentially like to do, I'm gonna share my screen so that is start actually with Rowan's pull request. So there is one that's removing meshing and then updates to bridges. So this pulls the mesh class out and puts it now, like everything's in discretized.
Yeah.
Which is nice because then like that fixes all the installation issues. With Windows machines, like it should just get installed no problem because SimPEG is pure Python. And then Joe went through and fixed all the issues with the discretized install.
Okay.
So I think like getting that in first would be good because I think we can pull that basically all the way down to master. It might be worth just checking out this branch and playing with it a little bit. So this is the feat/discretize. Because there are a few things that changed. So like you will need to update your PyMat solver because the way solvers are named changed slightly. So in this case, instead of importing like Paradiso solver, you just import Paradiso. So we killed like the solver backend with all the names. But then that of course changes a lot of your scripts and things like that.
Changes.
Yeah. And then the other things that change with this are just imports of like the mesh. So everything now, you can still from SimPEG import mesh, but you can't like from SimPEG.mesh import tensor mesh. That no longer works. You can do that from discretized though. So where you might see some of those changes, like if you just look through here, there's a ton of imports that changed. The other thing that changed, and I think this is a good idea, but it will probably impact some of your scripts,
Yes.
and definitely impacts like stuff I wrote early on.
Yeah.
Is just importing NumPy and SPy. It's no longer from SimPEG. So you just have to import those explicitly.
SciPy, yeah. Yeah, that's pretty minor. I mean, no break scripts, but whatever.
Yeah. So just like, as long as you're aware that that's coming in, it shouldn't be too big of a deal. So, yeah, and if you guys could maybe just like rerun your examples, the ones that you consider to be like things that you trust
On that
this
branch.
branch,
Sure.
make sure that they look reasonable, and nothing too crazy changed. Yeah, it shouldn't be too major, but like worth doing a sanity check before we pull it in. Yeah, and then once we get that in, I believe the objective function stuff is in reasonably good shape. I chatted with Joe about it when I was down in Colorado. He pointed out a few oversights or like odd complexities that I was introducing. that were absolutely necessary.
Okay.
So that's like it's a little cleaner now.
For instance.
So what I had done originally is we were passing back like the full Hessian from the objective function, which we don't need. You can do the vector product inside, and that simplifies the code quite a bit. In particular, when you have like reason that utils.identity. Because I was running into some weird stuff that like you need the shape of it, but it doesn't have a shape. So we had to like go in and sort of try and grab onto whatever you could to figure out the shape. Which, if you just do the vector product, you don't need to do it. So that is a bit cleaner. And I've also cleaned up how we add them. So I'll maybe show you guys an example. So if okay, so if we create a 3D tensor mesh, and we want to then do regularization. So if I have my break one is regularization. So this is also actually, in terms of names, I would appreciate your guys' thoughts in namespace. So we have like simple and deep enough, those are sort of the same as what they were before. But now, instead of smallness, I just call it small. I thought that like made conceptually a little more sense.
Okay.
Then smooth deriv and smooth deriv 2. And then there's simple smooth deriv. We don't have a simple smooth deriv 2 implemented yet, but it would be easy to have. So let's just take Tikhonov for example. So rate 1 is a Tikhonov regularization. So if we do you can see what things it has on it. So it has its alphas. And in this case, it will also have like the multipliers. So these are then the default alphas. So alpha S, alpha X, Z, and that's XX, Y. That's it.
Nice. So that, it's 0, okay.
Yeah, and so we'll do, in any of the objective functions, if you have a multiplier that is either a utils 0, like this guy, or a float 0, that's identical to 0, they just won't evaluate that. Which is nice when we want to start doing the coordinate descent style stuff, is that like we won't actually go through and compute a forward problem if we don't want it.
Okay.
Yeah. So it first checks your multiplier and is like, should I evaluate this thing or not? And then if it should, it will.
Nice.
And it takes the product afterwards. Whereas if it's 0, then it just says, let's skip that because we're not going to add it.
But like a little bit confused about, we got number 1, right? And then, is it like a 1 and 0 and 1 and 0 and 1 and 0, or like a
So why, and this is something I would like to,
So it's XX. Oh,
yeah, so
Oh, I see.
here, these guys match.
Yeah.
I would like to actually eventually have these named better, but right now, for instance, if I go in and do reg1 dot alpha XX is 2. That then updates this. So if you're using a directive or something like that, and you want to go in and change these parameters, that will work.
So multipliers and the objectives, are those something we should be using, or is that just for some convenience to have it there? I'm just thinking whether it should be hidden or not.
Oh, no, I think we do actually want to be able to.
So you want to be able to go into the list, and could I go and change?
Yeah.
Second item in the list to 2 and or
Yeah.
last
Yeah, you
item?
have total control over this thing. So why I think, and this is a question actually, is, well, that's
It
interesting.
did not change.
It did not change. Okay, that should be,
I see. So, like, you're thinking of this hidden variable or something like that?
Yeah, I mean,
Is that-
or like, I'm all for having a lot of options to do the same thing, but
Yeah.
that is really confusing for a lot of people. Like they're, or I mean, if we want people to set it one way or the other, why
Yeah.
should we have?
multiple ways to do it.
Yeah, and I would also say that they maybe should be a dictionary with the names and then the values, because then they're more legible.
Yeah,
I mean, if we want this to be accessible.
yeah, I mean, the thing I guess that gets tricky with names, and what's the list originally? There's two thoughts going on, we'll come back to this in a second. But is that I want to actually be able to do just state this, and so then my right. It has two objective functions. And two multipliers.
Okay.
And so we can just form that thing on the fly.
Sure.
Um,
And so those multipliers would be over, you would be multiplying over their individual, like if you do my reg that the first objective function dot multiplier. Yeah. And then for the second one. How come it didn't multiply everything by 2?
so it's because it does it on the outside. So it doesn't actually go,
Okay.
they're nested.
Sounds
So it basically, it pulls things on the outside.
But when it's going to do the multiplication, it will use the 2 on in front of reg 2.
Yeah, so what it'll do is it will basically, it'll go and it'll evaluate objective function 1, and then it realizes that, oh, okay, this is a combo thing, like let's go and evaluate all of those, sum that up, and then I need to multiply it,
Yeah, okay, sounds good.
and then it does the same thing with the next one. So these can be nested, which is nice, especially for regularization, is that you just want to take off as like one thing. And not worry about the fact that it's actually composed of the smallness, the sweetness, those kinds of things.
Okay, so kind of back to like the, let's say we have 2 times 2 NC model parameters.
Mhm.
Right now you're creating a regularization using mesh, right? So it's going to have NC cell dimensions. How are we going to do for 2 NC?
So what I would do there is, so let's then take my model, and so what we're saying is we've got some M that's basically like this, right? Okay, so I have some model that is my 2MC. So then in this case, all we want to do is define two mappings. So this is where you can use wires or just the projection. So if I do maps dot wires, I believe it just goes. I'm actually less familiar with that, so I'll just do, like, this is the way I would currently do it. You should look at wires because it actually is.
I'll send you a snippet that Rowan gave me, but yeah, I'm asking you because I'm still don't get it.
Oh. So,
Okay, so this is how it's so if we have map star projection is basically just it's just ones and zeros, it's an identity. So I use this a lot with parametric stuff because like I had a model that was 6 parameters long and then I wanted to send 5 of them here and 2 of them there. So it gives you that control. The wires is nice because it names your things. So it actually just builds you projection maps.
It's like a flat matrix.
Yeah, so here if we do this, and we do wires, maps, so it gets sigma map and that. So in this case, then all we want to do is like my reg 1 map is wires on maps. Oh, these are 2 post navigation. That's fine.
can you do wires.sigma map? Is that
Wires on maps. No.
interesting?
Anyways, at 0.
I think it's there. The wires that sigma. Wires that
Can you put it
sigma.
there? Yeah.
Oh, so this is the map.
Wires that mu. Wires that sigma. But
Okay.
then, so Roy was saying that this is going to zero out the portion of the regularization, right? But our regularization is in C large, it's not 2 in C right?
Right. So it won't zero out the regularization. It'll grab the structure.
Okay.
So
Yeah, I think that's.
so if we do shape of this map, it is 1,000 by 2,000. So all of this does then is if I do my this in this case my sigma equals reg 1 map times n. Okay, and then if I print the shape of that, it's 1,000.
So
now
it's going to be
it's in
in front of the regularization. Gotcha.
And so what this then does, well, it's between. So if you stick it, you have your W and then you stick it there and then you have your.
That's right.
Yeah. So you can then pass your 2 regularizations or your mappings to each of the regularizations.
Okay,
and
gotcha.
then stack them up.
Gotcha. I thought it was on the other side, but it's in front of it. Yeah.
Yeah,
that's
it's like smack in the middle. So the mapping is always going to take like whatever you have and then transform it into something that we can then work with.
good. So they're all going to be on the mesh, based on the mesh. And
Yeah.
So gotcha. That's good.
So for instance, like so that you have reg 1 map, reg 2 map. What like are you going to pass wire.sigma and
Yeah.
wires.mu? Is that
Yeah.
is that what you're going to
That's
do?
what I would do. So if you want to regularize on sigma and on mu, then here we've got reg 1 map and reg 2. I guess we need to define those. So if I then go reg 1 is T-count, and then mesh, and then mapping.
Right one. Yeah, gotcha. Then if you go to multiplication, if you do reg 1 times m1, times m.
Yeah, and then this is then just, right.
Um,
I'm gonna do an eval on it.
Dimension. No, so eval's been overwritten.
Oh, we're
with
oh,
the
right
fall.
now. Okay, okay.
Yeah, so let's actually see.
isn't it like just
So I've done mapping. It might be that the mapping, I'm not actually setting it correctly.
Or maybe MREF is by default in C-long. Can you double check that?
That's a good call. Oh, MREF is currently none.
Yeah, then actually that opens up that MREF should be pulled out. Like the mapping should be applied to both. I don't know, if you have MREF that is the same as M, that's fine.
Yeah, it should be okay. So what, let's see, right one. Yeah, so this should be 1,000. So the way I'm counting is
what is that 1,000? Like
because the mesh is 1,000. It's 1,000 cells.
yeah, so I think does it make sense? Like if your model is 2,000, right?
No, so because wait.
Well, that's I thought that's
Yeah, well, it should take something that's 2,000. So let's double check. So if I do. That works.
Can you check reg1.np? Is that, do you have that? Okay.
So it's probably that the mapping isn't being applied properly. So I can dive into that a bit. Yeah,
But that's how it's supposed to work?
that's how it's supposed to work.
Sorry, why is Reg 2 2,000 and Reg 1 1,000?
No,
they're both
they should
2,000.
both give 2,000.
Yeah.
Yeah, because they both should take something that is the size of your mapping in, and then translate it to something via the mapping.
Okay. So we're like at any single regularization, you always take the full model M.
Yeah.
Okay. See.
Yeah, because you always want to be able to evaluate the whole, like, I just want to say regularization of M. And that can be one thing that it actually ends up doing 10 things.
But even like even 10 single pieces, you always take the full M.
Yeah.
But sorry, Lindsay, that doesn't make sense because Reg 1 and Reg 2 were defined on mesh, right? All the gradient operators and everything are in C long, are 1,000 long, they're not 2,000 long.
Right, but your mapping takes you from 2,000 to 1,000. So it should always intake something that's 2,000 long.
Okay.
Yeah. So I think then somehow, yeah, you need to take into account and when you're generating those W matrices somehow, right? Like you're kind of squeezing your domain to a small domain usually. Right?
Yes.
Then
I mean, the mapping should do that. It's just not being applied properly right now.
okay.
So that's.
No, I mean when you're generating W matrices, like for each single
the
problem.
W is always generated via the mesh. Like it always asks about the mesh. It doesn't care about your number of parameters.
That's true. I see.
And then it does the mapping on the inside.
Gotcha.
Do you want me to pull it up?
Yeah. Okay. I see.
So let's see if we can figure out this bug anyways. So if we look, for instance,
Yeah. So I think those kind of things, like if you, well, that one's fine. I think that's a base regularization.
but I think what's happening is in objective function, we have forgotten the mapping. Yeah, so here in this case, in the call, I didn't check if there's a mapping. So if we do,
I still think that the NP should be number of cell, not total number of model parameter.
no, because you need to take, like the thing that we need to check on the outside is that the model, all of my regularizations need to take in the same thing, or else I can't add them together. So they all have to take a single vector, which we're gonna call our model. And that can be whatever length you want it to be. And so that is then basically, that's the length of the vector, and then you need, the mapping is gonna be then what makes sure that it's the same shape as the mesh.
I see. I don't know.
So like the size, the thing that it takes in, the effective operation should always be the same size as your number of model parameters.
And it'll cast it to the size.
I'm
of the
not,
mesh.
yeah, I understand what you're saying, but I think it's because they're down the road, like our regularization is going to be only looking at a portion of it. You know, we want to operate only on a portion of it. I mean,
Right, but you still have to give it the full vector. And then the mapping has to take care of the translation piece. But like because eventually what I want to be able to do is just call phi of n. And that then calls my data misfit, my regularization, all those things, right? But it needs to take in the same m.
why is that?
Because we only want to call one thing, right? So when we're doing the inversion, we're inverting for one model. Like if we're inverting for a list of numbers. I'm sure that might be sigma and mu stacked, that's fine. But we're still inverting for that entire thing. So I need to be able to give that whole thing to each piece of the objective function. And then it takes what it cares about.
Okay.
So like I think maybe some better error handling and then checking on the mapping to make sure that like you need to, if that is distinct from your number of cells, you need to make sure that there's a translation piece in there. I think that's a good idea.
Okay.
So in this case, with the issue, like we just need to apply the mapping here. And then same thing here.
Is that for data misfit, or is that like is this?
Right now, this is just like a base L2 objective function, so it doesn't even matter. Sorry, I should see. It doesn't matter.
That's a new thing, right? Like that's what you're working on, right?
Yeah. So actually, both regularization and data misfit inherit the base objective function.
I see.
Because it's just like W times the thing squared.
Just the delta W is a matrix then, or is that like a full thing? W is like take care of everything, like Is that regularization matrix or like,
It would be for each component. So in this case, like phi small is going to have its own W.
I see.
And so if you want to apply cell weights and all those kinds of things, it'll take care of
I
it.
see.
And then same thing, like now phi D
Yeah.
has a W, and that'll be based on your noise model.
Right. Can you open up the techno? Because I think that's taken care of in the previous regularization. That is
I might have broken that, probably. So like all Tikhonov is now is actually pretty lightweight.
Oh, I
It
see.
just inits itself with a
Oh,
small
I
smooth
see.
derivative,
Gotcha.
those kind of things. So I think basically in each of these, I just forgot to apply the mapping.
Okay. Gotcha.
Yeah.
Nice.
So I wouldn't mind hashing through this a little bit with you guys. Do we want to be able to set multipliers, or is that something? I think we do want to be able to set it, but perhaps like with like output that's shown, basically saying this just changed, with some logging basically.
Sorry, what?
So like this guy, when we did this,
It
it
didn't
didn't
work.
actually, I didn't properly propagate that change. I hooked it up to change the alphas.
Oh, I see.
So if,
But like we can still set the alpha X or like in that way.
yeah,
Yeah, that's fine. Right?
Yeah, I don't see the need to be able to set it both ways.
the reason you would want to be able to set it both ways though is because of like this. So if I wanted to change
I see.
a weight on the outside during the course of your inversion, that's actually a reason why you would want to change it.
Okay. So in that case,
Why?
But they're nested, right? Like you said, like one was on the outside.
So here, if I do,
Can
So-
you change that now? Can you do like?
yeah, this will work, and so this is, or it should be, interesting. So like, I don't like this behaving inconsistently between the regularization and this.
That's cool.
I think
Okay.
that's,
So that remembers, like if you do like if you put a if you put a scalar 1 and 2, and then set it, it remembers that multipliers somehow. Is that, am I right? Like, so can you run like a cell of 39? Yeah. And then 40? Okay. That's,
does that make sense?
yeah. Oh, no, I thought that's cool. Oh, okay.
But you managed to change your, in your reg one, you called it with the alpha XX and it worked, right? If you're doing like a list type of columns. So here you're saying you would like to be able to just use indexes?
No, it's just confusing having the same thing twice without having a clear reason why. Whether we, like,
Yeah.
it should be, like, if we change multipliers, it should change alpha, whatever,
Yeah.
and vice versa, if
Oh,
we
yeah.
want it that way. Otherwise, I would say we just don't have multipliers, or if they're needed, we should just hide them.
Well, we definitely need the multipliers, like that's how the objective function works.
Yeah.
So that's an essential piece. But maybe the thing to do is actually instead have the multipliers be like tuples, similar to what, like this,
Yeah.
basically, so that it can be named, but it doesn't strictly have to be named. So that like we can go through and you can access it either by changing like the index or by,
But then it should just be tuple of the actual alpha.
But
Or
like
something.
in this case though, then how do you handle that scenario?
I have no idea.
Okay.
I haven't looked at this enough, but just for me, it is confusing having an alpha and then multiplier, and then trying to explain to somebody whether you should do it through a multiplier or an alpha. Is it equivalent?
Yeah, I mean, it'd be absolutely true.
Yeah.
I guess the reason I kept the alphas is like, it's just how we often work with it and what we want, what's natural and all.
Yeah, I'm actually fine. Yeah, because the other one is more like it's more like a coefficient. Like it's
Yeah,
like those are alphas, and then the other things are beta.
yeah.
Whatever.
Or, like,
Different. Yeah, like it's balancing between different objects. Like this. Well, basically saying that. Yeah. Okay. Sort of fun.
Sure. I mean, I mean, I appreciate why we needed it. I would almost then say we should have something in my rack that would allow me to name 1 and 2 something and be able to
Yeah.
It's somehow like a naming it.
I don't know.
It's probably worthwhile. I don't know, like a
Yeah.
lambda or beta, whatever. Because
Yeah.
like, other things actually has a name, right? Alpha S, X, Y,
Yeah,
and then but this one like nothing. Then it's kind of rolled back.
it is confusing.
So probably like having such a name
Yeah,
that
If we just call the list of all the alphas, like alphas instead of multipliers, and then leave multipliers on the outside one, like,
I'm hesitant to call them alphas because it's the same, or to call the multipliers list, to rename that to alphas. Because in the same sense, like this is also how we can deal with beta, which is not alpha. But it is like a generic multiplier. But maybe if we have like multiplier names or coefficients or
I like multipliers, as long as I think as we can call it both in indexing and alpha XX or alpha X.
Yeah.
Multipliers is fun.
Sure. Yeah. I mean, I might be making more of a deal out of it than it needs to be, but I just find with things like these. I mean, we need to just explain that
Yeah.
they are completely equivalent, which they are at the moment.
Right.
So
They should be,
Yeah.
so we can fix that.
yeah.
Um,
And then on the other level, like the regular or my rack in the combo regularization, I guess, might be like, do we want to have the same ability to give the multipliers name?
yeah,
Just assign them. I mean, it wouldn't have to be gamma or whatever, but we could just, I don't know, John.
John and Steve.
Yeah, or something. I don't know.
Sure, so if we called, like, do we want then sort of MyReg dot, like coefficient names? Or just coefficients?
coefficients.
And then that can be the list of names or empty if there is no,
As you,
I don't know.
I'm happy
I
with multipliers. It's simple.
Yeah, I'm fine like that. I'm fine, but just can we like have certain whatever name behind, like that you can set it like in the same way that you can be.
yeah, and so I guess that's the question I'm trying to ask is like, do we want to, what do we want to call those?
Exactly.
What are the names versus, so the multipliers are actually the numbers,
Right.
and then do we want to call them
As a
like
flag.
coefficients, or,
Oh, I see.
do you see what I mean?
I see. So it's like that's equivalent of X, Y, Z.
Yeah.
I see. I don't know.
Okay.
You want to coin a Greek letter on this?
I mean, that could be something we add later. But just to have a clear idea of how you should.
Yeah, that's fair.
And then I personally would say that if we're wanting to change things through the multiplier, we should promote that even if enmity enough, that you should rather do it through the multipliers than through the alphas. Just to be consistent. But then again, it doesn't really matter. It doesn't really matter.
I like the coefficient.
Okay, sounds good.
That's what I used before to do that.
But what's going to be your name? Coefficient 1, coefficient 2?
No, I think you need just one coefficient, right? Like for this types of thing. Or
Well, I mean, here, so the coefficients, or whatever we choose, however we choose to name these things.
oh, I thought like a coefficient name is for reg1. Reg1 dot coefficient, and then that's isn't it same like because alpha x is defined for a single regularization.
So it's actually, it's a little subtle, it's not attached. So alpha s, for instance, is not actually tied to the smallness term. The only reason we need an alpha s is because we are actually summing it to other things. So the objective function list lives parallel to the multipliers. And that's also what lets us then do these early exits and things like that. Is that, you know, you look at your multiplier list first and say, which of these things should I actually evaluate? Then you evaluate in sum.
Oh, I see. So like alpha, so alpha for that, for reg1, alpha s actually lives in reg1.
Yeah,
I see.
yeah.
I see.
So, yeah, so it has its alphas. But then if we look at the like objective functions, so this guy is now just my smallness, and it doesn't have a multiplier.
Oh, it doesn't have a multiplier?
No, because it's just a single phi. It's like evaluate this thing. So as soon as you tack a multiplier onto it, it's then
I see. Gotcha.
a combination of things.
Okay.
And so part of why
No, I
tease
see.
those things apart as well is so that like when you're actually picking your multipliers, you want to actually just evaluate the function and like look at them both and then say, oh yeah, I want my beta to be such that my data misfit is like 10 times smaller than my regularization. So you want to be able to like handle the objective functions and then treat the multipliers as null outside of that.
I think that's pretty cool.
I see.
So out of curiosity, then, how do you do is the data misfit, is that also a combo misfit now? Or is that a single objective
So right now it's a
or single object?
Yes, very important. So you look at our L2 data misfit. It's still, I guess I need to survey and stuff. I'll show you the code actually. So this is all it is. I mean, you create it with a survey, same way as you would before. But it's just, when you create just a single data misfit, it's just a single phi. Like there's no multipliers attached to it until you like do what we did with the regularization. You multiply it by something and add something. So you can still add together two data misfits, and that will act as a new data misfit. But yeah, you don't have to.
And same thing for wires.
Yep.
Yeah.
Yep.
Slap a mapping in front of them.
Yeah. So that's something right now it probably actually would fail, but I'll take a look at that and get some tests in with exactly the example that we just should fail.
Okay. That's cool. Huh.
So then, yeah, we have all the pieces to start doing join.
Yeah. So like if you have an example, that'd be awesome. We can start.
You provide an example and then
Well, I think that the susceptibility inversion, I think that's a great example. I think doing either like a simultaneous inversion and then or like cooperative inversion, like those two will be a great example.
Yeah.
I guess. Yeah. Then we can move on to multiphysics. I guess, like say about mag and gravity or mag and whatever.
Yeah. So this one, because there's so much new stuff too, I would like to like get Rowan's pull request down, and then we can let this one sit on dev for a little bit and like break some things, because there's gonna be weird things.
Yeah,
that you're
it
gonna
needs
encounter.
some time, I guess.
So, yeah, if we can get the kinks worked out.
Well, it'll open a whole bunch of new things, right? Like, say, like in math, you want to estimate your constant stuff, you can invert together. Those are actually like simple wire math, like put a constant in your inversions.
I'm ready to use it.
Cool, okay, well, if the mapping's fixed, and then that should be hopefully enough to start playing with it, and, yeah. Breaking some things.
Exactly. I tried to pull your branch in, and then it was like, it's a little bit too much work, but if you have an example that works, then I'll do it.
Okay. Yeah, sure, I'll try and get an example of like EM with permeability.
Yeah. Is it gonna work like this? Because before we put active indices for regularization,
Yeah, that's
to take care of like things like that.
Yeah, all the tests that were there before for regularization are still there, so still like. those
So I can do
things
the
are still
same things like say that 3 parameters, and can I like make 3 different regularization? Taking off, then can I pass the same like active indices here?
It would be passed after your wire, right? So you would pass your wire map, and then you tap on it, the active.
Pass them both at the same time. It should.
But dimension-wise, you want to send your wire first,
Well, operation-wise, yes.
Yeah.
But in terms of just instantiating it, it should be fine. Because all you're doing is basically saying, I have a mapping and I have active indices. And then in the code, that should then take care of like apply the mapping, apply the active indices, now do a regularization.
Right.
So the order of operations should take care of that. But you specifically don't, you can pass them both at the same time.
Because there's a difference if you use that mapping, it doesn't take care of that like boundaries. Like it doesn't set that as like a 900. It takes a derivative between. I mean, I thought that was the reason why you set like that as an active indices, like taken care of like this air surface.
Yeah, no, we're saying this. Yeah, I'm just saying the order of operation is important. Yeah.
Right.
Hey Joe,
Hey guys, how's it going?
how's it going?
Fine.
Oh.
Thanks talking about regularization stuff. It looks like.
Yes, yeah, thanks for your input on that. There's still a few things
Yeah.
that are issues, as you probably tell. Yeah, but thanks for your thoughts on the Hessian and simplifying that. That makes life so much easier.
Yeah. I mean, it's just never made sense to me, like how often you would ever need the full Hessian. Because, I mean, like I said, every time you're using a regularization, you're adding it to a data misfit term that almost never has the full Hessian.
Yeah. So that was just an oversight, but very helpful to get another set of eyes in there. And then you've been pushing on interpolation stuff?
Yeah, a little bit. I was cleaning up some of the Python code and making it more Python-esque.
So awesome.
If you want, I can kind of show you a few little things that I was doing with it really quick.
That would be great.
Okay. So one of the things that you can make really good use of is, so Python has if you run Python from the command line, you can give it the -a option to it and run that on the file. And what it does is it creates a HTML document that kind of highlights where things are calling Python, where it's calling the Python interpreter, and where it's actually gone down to C code. So this is basically this file. Right now, the one I've changed. Let me show you the one what it looked like before. You see here, like this is one of the loops where it's looping over all the points. all these yellow lines require a decent amount of Python calls. And it's kind of highlighted. Like, so this is what the C code looks like behind it. And all of these red things are Python calls to the Python interpreter, which slows it down, right? But the point is we want it to be fast. You want it to be C code, really, right?
Yeah.
So there's a lot of issues here. Like, for one thing, these are list, you're using list appending, you're appending the lists over and over and over again here, which is slow. We know how big they're going to be, so you can just allocate them ahead of time. But one of the things that's happening here, so if you can see this function, at the very top, it's just a bunch of code that's basically initializing the function in Python, which you can't really get around because it's a defined thing here.
Okay.
As opposed to C define. It's a little bit of a subtle difference. But yeah, you still have the static typing here. But even this little line here, right? You might not be able to see it, but it's very faintly yellow, and it just raises this little index error here if you go out of bounds. Same thing here. But then once you get down to all the return statements and see here all the calls to Python that it makes, and then these other every time you call the Python, you slow it down. So you kind of want to get rid of that, and you want it to be faster. So I've basically replaced that with these functions. So first of all, the big motivation was this line is not very fast. It's order H, and you can do the same search in log H time. So basically, you use a bisection algorithm to do that. What you do if you have a sorted list, you compare it to the middle value, and if it's less than the middle value, you look only on the middle half or lower middle half. If it's greater, then you look in the higher middle half. That's the order H improvement right there. But if you see, the whole algorithm is implemented without any calls to Python at all. So it's all C code down to here.
The Cython decorators, what do those do?
So the first one, it basically does exactly what it says. So the bounds checking, it just won't check if the array indice is within the bounds or not. So I've implemented it in such a way where it'll never go outside the bounds, so I don't care. So I don't want it to check. I've also turned off wraparound indices. So in normal Python, if you use negative indices, it goes to the back end. So by default, Cython will mimic that behavior, but you can tell it not to. And then there's also this other little thing. It does a few checks if variables are nuns as well. So I just turned that off because they should never be nuns coming in. But the key here is this function that's been defined is defined with C code. So the C defined here. And then you tell it what it's going to return, just like a C function. And it's called without the global interpreter lock here. So the global interpreter lock means that this function can be called without telling Python to wait for it. So you use the global interpreter as this thing. So you can't really ever run Python code natively in parallel because of the global interpreter. Only one thing can be interpreted at a time ever with one Python process. That's why when you run things like MPI, it spawns multiple Python processes. But other than that, so I've got two here. One's a left bisect, one's a right bisect. I was just trying to mimic what the code did before. I realized I was using the left and I needed the right, but something else. And then here's this function here is basically implementing in C what this function did before. So all of those yellow Python calls I've gotten rid of, and it's all goes down to C code. There's no Python executed at all. Another thing here is I've told it to use C division, so I'm not using Python division operations. So it just kind of speeds this step up here. And then when you're actually building the interpretation matrix vectors, remember those big loops that had Python calls in them? This is that same loop without any Python calls. So the loop executes much quicker without that as well. So
Right.
that's just kind of things you can do with Python, just to get beyond static typing. This little comparison between, like when you look at the HTML interface of the file from Python, it really gives you a hint of where you can optimize things further and where your slowdowns are going to be coming. So like if you look at the 3D interpretation matrix, like all of these calls were to Python.
Yeah.
So like Python wasn't really doing anything here.
Right.
Oh, I see.
Just making the installation part.
Oh, I see. Oh,
Right.
okay.
That's really cool, Joe.
If you just do Python on a Python file, it'll run the same way that Python does. Because it's just doing the same, it's literally doing the exact same thing. So the key here is that it didn't know, like, there's all these calls that need to happen just to do that one statement. So this is just this one line here, just this one line. And then, like I said, when you go down here, this is that same 3D matrix. It looks a little bit more verbose, but it's all down to C code. Yeah, that's about what's going on there. Another thing, what else? So this is kind of Python's old way of taking in NumPy arrays. If you're doing it now, it's better to do it this way.
Okay.
So what this is called is a memory view. So it works with multiple different. It works with just regular Python lists. It works with NumPy arrays. It works with Python arrays. It works with C arrays. The thing is, when you pass it a NumPy array, this only works on a NumPy array. You can't pass it really any other type.
Oh.
But this thing is just as fast, and it also works almost exactly like a NumPy array. They're called memory views. So
memory views?
Memory views.
Okay.
That's just little Python implementations and how you just have to know how to get down to C calls. So the key is defining these C-defined functions. So these actually are not visible to Python at all. They're only defined within the C functions. So I couldn't call this bisect right algorithm in the Python shell.
But the insert map 1D, you can, and then that's why we have to hit Python when you're actually defining those NumPy arrays.
Right.
Okay, cool.
So like here, I'm just so this is another NumPy array. I'm just kind of initializing here. But it's quick. It's a little bit faster. And then just kind of comparison, if you go look at the tree mesh file, the tree utils.pyx. So this little bit function here, it's pretty good. I mean, it's just this, there's not too many calls to Python here. But then once we're down here, basically these are still Python. This is still Python. Not as much, but still Python. So a lot of these indexing is still Python, even though it's written in Python. So that was the next thing I was looking at, is trying to figure out what is going on with the tree mesh.
Right. So you need all the Pythons.
Yeah.
Cool.
So yeah, the key is Python -a. If you want to do Python, if you want to look at how it's going to translate down to C code.
Sorry, Joe, I've got to run, but I will leave you with the rest of the team here.
That's about all that's all I had on Python stuff.
Use my computer.
I mean, you can also do a lot of things that you can with C. You can, like malloc and alloc, dealloc arrays if you wanted to. You can use all the C functions if you just import the right header files. So I've mostly used Python as a way to link in precompiled Fortran codes So I've got Fortran codes that are compiled with the ISOC bindings, and you can just statically link to those codes with Python, kind of the same way that you would to any other C code. Yeah, that's about all I had for Python stuff right now.
Nice.
So that's your plan. You're slowly going down the like the basic functions and transfer as much to C as possible. Is that what you're doing?
Might as well, right? I mean, if you're going to use Python, if you're going to use Python, you might as well use it to speed up stuff.
Yeah.
Yeah.
Thank you.
Do you have any experience with NumPy? NumPy?
Oh, the NumPy, like NUMBY thing?
Yeah.
No, I don't. Sorry.
No, I mean, that's supposed to be some sort of a wrapper onto, I guess, C, optimizing your code.
Yeah.
I've never gotten it to work in the couple of hours that I tried it for. Didn't see any difference. So, just curious.
But still, a lot of, so like I said, I think the next thing with the tree mesh is that code is very slow. Like the interpretation matrices on that code is very slow. It's almost all like it's all Python code. It's not even Python attempting to be Python. It's not Python attempting to be Python. It's just Python. So it's it calls a little bit of these things. It calls some of the functions from this interputils, but not very efficiently and not over large arrays. It calls it for like one face at a time or something like that.
So same thing is happening in oak tree, like a tree code as well. Like there are lots of codes, and that slows down.
So like this is just the tree utils, right? So then if you open up actual tree mesh and see where it does that interpolation. So right here, like it's looping over all of the cells.
Oh, I see.
And this is a Python file, right? So it's doing all of these calls are in Python.
Right. So that's gonna.
So it's not going to construct that matrix very fast at all. It actually takes a while to construct that matrix.
Huh.
But there's a lot of stuff going down here, like.
That's true.
This thing here is all in one line.
Thanks.
So it's just a matter of me trying to understand what is going on here, because I don't have that much experience with the tree meshes.
Yeah. That's man. Sure.
Yeah. Then, like I said, the point here is like it does call these interputils things,
Right.
but this array is maybe what, one element there, and then this has two elements, 2 or 3 elements. Like it doesn't call it; it only calls a little bit of it at a time. So that's why it takes a long time to construct that interpolation matrix for the tree mesh.
Hey, do you have a way to get the clock speed of each line? Do you have like a software that does that? Piece of code?
To do the what? This?
Well, just to know the execution time for each line of a script.
Not necessarily. More just a timing thing.
There's
the time it. Yeah, you could do profilers on it, but it's most of the time it's pretty obvious where some stuff is coming from.
Rowan with the wrapper. There's actually pretty good.
There's also, if you just Google notebook built-in profile, you can get kind of time per execution. But I mean, I've tried it on SimPEG and it just.
Oh yeah, because it's counting so many.
Yeah, you can do it on like a couple of lines, but otherwise you just because it will go into.
Mm-hmm.
It's very hard to interpret.
Yeah.
do it on a specific thing.
Sweet. You'll be able to teach us tree mesh after once you're out of this.
That sounds good.
When you came out of the other side.
Oh, I have no idea what's going on here yet.
I think there's only Rohan, right? That kind of like knows what's in tree mesh. I mean,
Yeah, I'll definitely have to talk to him more about it. But
Not seriously enough to really get an understanding of it. No. I tried
I
to
mean,
play
I
around
looked
with
at
it,
it.
but
Yeah, I looked at it a little bit after we rewrote it. Because I mean, it's much more efficient now than it was.
yeah,
But yeah, it's some interesting kind of linear loop. But when you refine it, just kind of breaks it up. Kind of just so you're just kind of snaking around. Kind of physically when you're doing it, and it just knows kind of how to map itself to its neighbors.
Yeah.
I mean, it's relatively easy to work with, but
Mhm.
there's some operators that aren't working and not implemented correctly, or not implemented.
yeah, for the regularization, we still need a couple operators, I think.
Yeah.
Or the base one is there, but we just need to.
So,
You start getting weird things when you're inversion, basically where you at the boundaries where you get changes in cell size still at the moment. So Lindsay thought she was really close to like knowing where that was that she needed to take care of that. She thought it was just like some hanging nodes and some hanging faces that were still there that needed to be dealt with. But so sometime soon, hopefully we'll be able to hammer that out.
that'll be fun.
That would be good, yeah.
Okay. Sweet. Is there anything else?
I'm good.
Perfect.
Thanks, Joe, man.
Yeah.
nice seeing you again.
It's Joe.
Have a good one. Stubble project.
Yeah, step back, yeah.